and we are going to study first chapter in physics, that is electric charges and field. For this, let's revise some points of 10th class related to this chapter. Your first point is charge. As we know that there are two types of charges, positive and negative, and its symbolic representation is q and its SI unit is coulomb. The second one, like charges repulse each other and unlike charges attract each other. We know that. Now, methods for generation of charge. First method, charging by conduction with direct contact. If we take two bodies of same size and material in which body A is charged whereas body B is neutral, and if we make a contact of body A and body B, we are seeing here that some of the charge transfers from A to B. This is known as charging by conduction with direct contact. Now the second method, charging by induction. As we know that a neutral body has same amount of positive and negative charge. It can be represented in this manner or this manner also. If we bring a positive charged body B nearer to A, positive charge of B attracts the negative charge, and so the negative charge comes nearer face towards B, and positive charge repels the positive charge, so the positive charge moves to the farther face of A. In this way, we can see here that partially negative charge appears on the nearer face of body A and positive charge appears on the further face of the body B. This temporary electrification is known as electrostatic induction. This temporary electrification on the nearer and further faces is known as electrostatic induction. Now, if you connect this to the earth, as we know that earth is neutral, so the positive charge of this phase moves to the earth and your body A will become neutral from this side. Now, if you remove this body B, you will find that body A is completely negatively charged. Let's discuss the next point, charging by friction. We are seeing here that if we remove one electron from this sodium atom and this electron transfers to chlorine, we are getting here sodium positive ion whereas chlorine negative ion. So from this we are seeing here that charges are generated by the transfer of electrons. So let's see how this charge can be generated by the friction. If we comb our dry hair and bring this comb to the small pieces of paper, the comb attracts these small pieces of paper, and we say that the comb is electrified or charged. That's why it's attracting the small pieces of paper. Now, what is the reason behind it? During rubbing, because of the friction, heat energy is generated and absorbed by the outermost electrons of the atoms, and so they transfers from one body to another. In this way, both the bodies are charged. As we have learned in our previous classes, that sodium, when transfers one electron to chlorine, it becomes sodium positive ion and chlorine negative ion. So, sodium atom gets positively charged whereas the chlorine atom gets negatively charged. Note, from this we find that by the transfer of electrons, charge is generated. Now, next topic is quantization of charge. Here we are seeing the body. If one electron transfers this body, we get plus 1 e charge on this body. If two electron transfers from this body, we get plus 2 e charge on this body. And suppose if n electrons are transferring from this body, we get plus n e charge on this body. Okay. So we are finding here by the transferring of electrons that plus minus 1 e charge can be generated on a body, or plus minus 2e charge can be generated on a body, or plus minus 3e charge can be generated on a body. It may vary by the number of electrons transferring. So from this we can conclude that the charge can be generated on a body is in a form of q is equal to plus minus anywhere, n is equal to 1, 2, 3, or and so on. Now next topic, Coulomb's law. Coulomb's defines the force of attraction or repulsion acting between 2-point charges. If we are wishing to find the force of attraction, the amount of force of attraction or repulsion acting between 2-point charges, Coulomb's defines this. Let's see here. Let two charges q1 and q2 are separated by r distance. So according to Coulomb, the force of attraction or repulsion acting between these two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Now on combining these two, we get F is equal proportional to q1 q2 upon r square. Now on removing this proportionality sign, we are using a constant that is called electrostatic force constant K, and it may be represented in a form of 1 upon 4 pi epsilon naught, which have a value of 9 × 10 to the power 9 Newton meter square per Coulomb square. So if you put this value of K here, you will get this formula. F is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. Here naught is representing that your charge system is placed in vacuum or free space. That means this force is acting in free space between two charges. Now what will happen if the whole system is put inside water or an oil? The medium is changed now. Let's see here. Now force in medium according to Coulomb, 1 upon 4 pi epsilon q1 q2 upon here. We are seeing here, we are not using naught because naught symbol is used only for the free space. Now let's see here. What is the epsilon naught here? Epsilon naught. What is epsilon naught here? It is absolute permittivity of free space. And what is epsilon here? Absolute permittivity of medium. What amount of the medium is permitting the force between two charges is defined by epsilon, and what amount of free space is permitting the force is defined by epsilon naught. Now if we divide these two, we will get a constant. We know that if you divide two quantities, you will get a constant. Now here it is represented by K or epsilon r. This ratio is known as relative permittivity of medium. That means with respect to free space, how much the medium is permitting, we can find by this. So if you cross multiply, you will get epsilon is equal to epsilon naught K. Putting this value over here, you will get 1 upon 4 pi epsilon naught K q1 q2 upon r square. Now if we divide equation number 2 from equation number 1, we will get F medium upon F naught is equal to this. On removing these, we will get this. Now if you transfer this one, you will get this. So this one is here. We have got the Coulomb's law.